Good afternoon, everybody. I'm Ralph Kohler from the Air Force Research Laboratory, and you guys know we've been doing a lot of focus on AI/ML, and one of the things that makes the TAK ecosystem great is that we're in control of our data. This is who's going to talk when. I'm just going to say a couple of things about why this is important, and you guys probably don't care about the detailed agenda anyway. So the thing about the TAK ecosystem is TAKServer is a mechanism for collecting all that data, but we don't do anything with that data. Who here uses their TAK data today for machine learning? Excellent. Yes, yes. Who thinks they should? Thank you. And so what we're trying to do here is to build and deploy a system which will collect, organize, allow you to filter so that you can then build models and then have a mechanism either inside or outside of Watchtower to deploy the appropriate model at the appropriate situation. So you might have, in the case last talk with Nate, Nate didn't do a demo of the paramedic GPT, but we got one that I assume he's going to show in the other room. Or the rescan people got a model to do context for inside of building ID. And so you want to be able to deploy multiple models, and you want to be able to train on those models, and you want to be able to build those models. So we're trying to build an ecosystem, a circle here, to collect, organize, deploy the data and the models. And we did this via 3 SBIR topics, and for most of the work here, I won't go into detail now, we have rights to leverage this. And when Nate talked about the data hosting at tak.gov, Ryan McLean helped me put this project together several years ago. The data that we'd like to have hosted there is the data that users who want to collect and have that data organized put there so we can do data at scale like we're a real program. And I think this is eminently possible, and I think we're on a great track to do that. And also, something nobody else is going to talk about here today is that we are working with our international partners in FMS to bring them along to the same thing. Now, if you're an organization, by the way, that wants to collect, organize, and use their data but doesn't want to share it, that's fine. Our aim is that you're going to be able to collect this data through TAKServer. I hope have it tagged and organized right through TAKServer so it'll all be automatic. And if you want to have your own private enclave, that's fine. Okay, that is what I have to say on the topic, and we have 6 performers over 3 topics, and I'm turning it over to them now. Ryan from Certus is up first to talk about, we're going to talk about the sexy model development first, which I must say, I think is awesome. Ryan, it's all you.
All right, thank you, Ralph. So, all right, so I'm going to kick things off here by talking about one of our D023 servers, the tactical employment of audio with mobile machine learning, or TAK-Mil for short. It's going to be a bit of a, get through this pretty quickly. We've got a lot of ground to cover in the next hour, so apologies if there's any more details you want. If you are interested in more details, all afternoon tomorrow we're going to be over in the demo room, so please feel free to stop by and come talk to us. So TAK-Mil is a collaboration between Certus Innovations and RTX BBN Technologies. Both bringing different perspectives on machine learning and different areas of expertise to the table. So Team ML specifically is about bringing the audio ML world up to closer to parity with the rest of the ML world. So audio is an important signal through which we perceive the world, probably, arguably for most people, second only to vision in how they orient themselves and classify the world around them. But that said, in machine learning specifically, it is a very undertapped modality. So you can go onto Papers with Code right now and find 10,000 different implementations and data sets and benchmarks for computer vision models. You'll not even find 1% of that for audio models. So why is that? And the answer is because it's just not as sexy as GPTs and computer vision and that sort of thing. But it is still very important. And these models they've been undertrained. It's an under-tapped market, especially in the TAK ecosystem, when we have all of these sounds that are relevant to military and public safety environments like gunshots, helicopters, and increasingly UAS that we want to make sure that we can process on the edge devices and deliver that information to the user in real time. And then specifically, we have one important sub-project that focuses on voice. Right? Primary and effective means of communication for tactical operations, collaboration, and planning activities. Hopefully that's not too controversial of a statement. But due to the global footprint of the United States military and other non-military organizations, we often encounter situations where operators don't share a common language, and this can be a barrier to efficient communication and collaboration, which is something that we can help bridge with the TMML project because we can use machine learning to help to provide translation, speech to text, text to speech at the tactical edge. And the program that does that is called TAK Talk. So TAK Talk provides near real-time voice-to-voice communication over constrained comms, so mesh networks, LoRa, hypothetically LPI, LPD waveforms across different languages, so you don't have to share a language with the recipient. We've tested English to about 7 different languages. We've tested Spanish to Swedish, Russian to Swedish. That translations made sense in context, and it all works out pretty well. And it does not require a TAKServer, so you can use one, but all the processing is done on the edge device. And we can see the ConOps here. You speak in your native language into your phone. The speech to text converts that into text. The text is what's transmitted, and this is where we see the 98 to 99% bandwidth reduction versus sending raw audio, which allows us to operate over those resource-constrained networks. The text shows up in your language on the recipient's device, and then optionally, machine translation is applied to convert it into their language, and then speech to text will read it back to the user in their native language. There is also an optional 4th step where if you have created a voice clone profile for yourself, that'll be disseminated to the recipient and applied post hoc to the synthesized speech. So even though it's speaking in the recipient's language, it will sound like it came from you. So our current status is we tested it at Northern Strike 25-2 with some Lithuanian teams. We got some impromptu tests with some Dutch and Norwegian teams earlier today over in the other room. Pretty good results there. It's available as a TAK plugin for modern ATAK systems. You can find it on soon on tak.gov, and a little bit after that it'll be available from the Play Store. You have many relevant languages, English, Spanish, Ukrainian, all the other ones that I mentioned previously. And we do have a more military-focused option that uses Cyrus, which is developed by BBN Technologies, which is resistant to military background noise and specifically dialed into the military use case for the types of jargon and constrained grammars that you would expect from radio communications. So going forward, we want more languages, more integrations, but it is in a usable state as of today. Switching gears a little bit, we have ASML, which is audio for aircraft. The idea is, can we use the TAK device as a low-cost sensor to detect, classify, and possibly localize aircraft, specifically UAS, in real time? So, as you can see here, there's been a lot of and an increasing number of drone attacks on U.S. military bases around the world, which have resulted in multiple U.S. service member deaths. So there are systems that can counteract these threats. Curve radar is great if you have curve radar, if you have the money, the infrastructure, the footprint on your base for it. But what about if you don't have access to that? So ASML helps to mitigate these problems by providing real-time audio-based detection classification on the user's device without needing to call back to any kind of server. ASML is in a similar position to TAK. It is ready for field testing, not quite as polished yet. We're about to move into the field testing phase. If you want to see what the app looks like, you can come see us at the demo table tomorrow. For obvious reasons, I cannot test a helicopter detector in this building, but we can at least show off the app. In the interest of time, I'm going to move on to our next project, which is DART. So similar to ASML, DART is audio ML specifically for gunshots. If everyone already has a phone with them or another wearable TAK device, then everyone has an audio sensor that can be used to detect, classify, and possibly localize any gunshots that can be picked up by that microphone. And this is important because, if you're in a very stressful situation and you hear a loud noise, was it a car door slamming? Was it fireworks? Was it a gunshot? Right? It's hard to make that determination, especially if you weren't paying attention in real time and be accurate and confident in that decision. And this is something that the machine learning model can help with. It can also classify the type of gunshot. So you might respond differently to 5.56 NATO versus 7.62 by 39. Right? That indicates a different type of person is shooting that gun. And we haven't developed this yet, but we're about to work on it, localizing the origin of the gunshot. So, okay, there's someone firing 7.62 by 39 over there. What are we going to do about it? And the idea is that it helps you and your team to maneuver effectively with accurate and up-to-the-minute information. So in the interest of time, basically, this is in the same state as ASML. If you want to come take a look at it, you can see us at the demo table tomorrow. I'm not going to demo a gunshot detector in a crowded auditorium, but I promise you it does work pretty well in our desktop testing, and we can show you how the app works later if you're available. All right, so just to wrap up real quick, ML is still very much a nascent field. A lot of the tools are still feels very Wild Westy. As my ML tech lead says, the only people doing ML are tech bros and grad students. So a lot of the tooling that you need to be an effective ML engineer is just not there. And so that is kind of the framing narrative that I want you to keep in mind as we go through these next presentations, is that if you want cool ML models delivered to the operators quickly, all this tooling needs to be in place in order to support that functionality. And that's my time. Thank you.
Good afternoon, everyone. My name is Benjamin Fenelon, and I'll be speaking on behalf of Kitware as we introduce our contribution to the CivTAK, the ATAK plugin. That is the automated recognition and cataloging plugin for TAK. This wouldn't be possible without all of our wonderful subcontractors, as well as all the other Civers a part of this effort. There you go. Great, yeah, so recently we've seen explosive growth in AI, and it's allowing us to bring AI to the forefront in applications. Particularly, we're looking at bringing AI to the forefront of warfighters' hands, literally in their hands with mobile devices. We're looking at leveraging state-of-the-art models, as well as state-of-the-art hardware in our devices. We want this to be applications that can work independent of cloud resources, working fully functionally on our mobile device. We're looking to have something that will work always with the right data, with the right models, in the right place, at the right time. And in order to support these applications, we need a variety of infrastructure, as is possible, we'll see throughout the course of this presentation. Particularly, our effort here is on automated recognition and cataloging. Here we're looking at building a static as well as live stream gallery that is queryable resource, either through natural language queries. This is through a physical description of an individual, as well as segmented scenes or check-in photos that we can take from our camera or from a gallery that is just on our mobile hardware. This involves a variety of different data sharing platforms. So again, this can be completely offline, or this could be on an online setting where we have live feeds. Now we can take a look at this application in motion with a quick video. So here we are just waiting for TAK to load. And here we're going to pull up the ArcTAG plugin. And I really advise you to come by all of the demo tables tomorrow afternoon. We'll be presenting the stronger current version of this application. But we're demonstrating here, opening up a plugin that's going to prompt us with how do we want our input modality. For here, we put in a scene, and we're able to guide our SAM2 model to a particular point that we want segmented out. That segmentation mask is transformed into a bounding box that is transformed into an appearance vector that is used for person re-ID. We're provided a gallery of search results based off of that appearance vector, and we're able to click on individuals that we care about from this listing, and then we can pull up a dossier view to see all related tracks as well as their geo-registrations on the map of these tracks. You can imagine a live feed of this happening where we're actively clustering tracks to try to determine new individuals, as well as this static database view where we have all folks nicely labeled as we would for a trained model. Now, it's taking me a bit of time here, but I can also type in a textual query, get a description of a man wearing a backpack, and you can imagine the search results of a variety of folks that it has encountered with a backpack. Now let's talk about these AI models. Obviously, AI is at the forefront of this plugin, but there's a lot that goes into actually making this a functional application, particularly our styles of optimization for getting this to run offline on hardware. We have two methods of optimization here, one using the Vulkan runtime. This is also a work in progress. Particularly, we want one sort of static model definition such that it can be used for a variety of different GPU environments. As we demonstrated live here and on our demos here with S25, S24, and S23 devices, we also utilize Qualcomm's QNN runtime. So we do a bit of processing, and eventually we get all these nice state-of-the-art models running on specific NPU chipsets for these Samsung devices. We have a variety of runtimes here. As you can imagine, the more specialized you get to the exact hardware that you have, the faster the model is going to be. And just for reference, this is one of our bulkiest models. This is the Meta's SAM2 model, responsible for all the segmentations. You can see something really device agnostic like CPU model takes an annoyingly long amount of time. However, as we scale to the most recent hardware with this specialization, we can get fractions of a second. And just for folks that care about it, Vulkan is about 10 times slower than some of these other QNN models, so still usable, but keep that in mind. Okay, so now we've taken our first step for the image-to-image re-ID problem, and that is getting a bounding box to present an appearance. And so once we have a bounding box, we have our personally trained ResNet model specifically for a particular environment that then translates image into queryable vector for our on-device vector database. And you can see here now our model speeds are incredibly fast, regardless of the optimization. So a lot less prohibitive. Alternatively, you could search for individuals with descriptor vectors or in natural language queries. Here we're using a vision language model, particularly STGLIP, but the model doesn't particularly matter. All we want to do is have text be translated to a similar vector space such that we can evaluate it against our vector database of images. Also, we have quite a speed here with our QNN models. Again, Vulkan being about 10 times slower, but still very usable. Now, I'd be remiss not to mention kind of what is this data that we've been seeing throughout this presentation. This is one of Kitware's publicly released data sets that you can find at mivadata.org. This includes all of those geo-registrations, though you might have to do a bit of wrangling for all of the tracks that exist. So we've been presenting on exemplar re-ID, that is taking one exemplar frame from these tracks, but we have all video track data. This is about 1,000 tracklets of 154 individuals with varying outfits, scales, indoor, outdoor scenes. But in future iterations, we're looking at having data that is collected, filtered into annotation tools like Fuel AI that can run our models, gather embeddings, and allow this to be something that is packageable onto our device, something that is provisioned into mission-critical scenarios. We can also imagine live streams where we have our camera systems, for instance, from the DARPA URSA program, where we have live detection, chipping tracks, and giving us the data needed either for annotation or for live clustering. Now, as I started this presentation, we're talking about having the right models with the right data at the right time in the right place. Well, this wouldn't be possible without the support of all these different applications that we're presenting throughout this presentation. In addition to this, we're also having continuous training services where, okay, we have this re-ID model that works very well for appearances in the MIVA data set. Now what happens when we translate to new domains, new areas? Well, we want constant retraining to ensure that we have specialized models. And then we also want something that can be provisioned. We want data that's annotated from Fuel AI. We want models that have been specialized to new chipsets, and we want these packaged into one particular plugin, and that's where we're looking to Watchtower for getting our devices up and ready for mission. So I'll now pass it off to those folks talking about publishing and deployment activities.
Hello, my name is Joshua Lopez. I'm the lead developer at Technergetics on the TAK UEM effort. So just to give a brief overview of UEM. So the purpose of UEM is essentially to provide TAK users with a means to quickly discover and apply machine learning models that best fit their operational needs and use cases. But our goal is not only to put models in the hands of TAK users, but to further development of these models by fostering constant communication between the TAK end users and the model developers themselves. So the idea is a TAK user might pull a model from the UEM system, run it in the field, gather some sensor data, and then all of this information gets relayed back to the model developer who can then analyze it and potentially use it to create a revised version of the model, which then gets pushed back out into the UEM system and back into the hands of the TAK users. And this system benefits model developers who gain a better insight into how their models are being used in the field as well as how they're performing, as well as TAK users who are supplied with more revised and more effective machine learning models. So we have a video clip of our model marketplace platform, Wingman AI, which is at the forefront of this system. And Wingman AI was designed to streamline the model development process from model creation to testing and revision. And at a high level, Wingman has two types of users, the first of which being model developers who are looking for a platform to upload, run, and test their models. And then you have TAK users who are looking for specific models to solve their operational problems. So why would I want to upload my models to Wingman AI? If I'm a model developer and I'm looking to produce the most efficient, most refined model possible, that's going to take a lot of testing, a lot of revision. Wingman makes this very easy by giving me the option to expose my model to a wider audience that's made up of other model developers as well as TAK users who can provide me with invaluable feedback, which I can then use to push updates to my model. I can also use Wingman's metric tracking service to see how my model is being utilized within the system and how it's performing. And conversely, if I'm a TAK user who's just, say, looking for a detection model to detect different models of helicopters, and I need it to run on my Samsung Galaxy S23, I can go to the Wingman model discovery page and enter my criteria and be shown a list of models that apply to my use case. So we have a video of what the model upload process to Wingman looks like. Is that playing? Oh, there we go. Okay. So throughout the UEM effort, one of the main questions that we've been looking to answer is how can we expand the outreach of Wingman and its features to TAK users in the field. So to accomplish this, we've been working in collaboration with Sherpa 6 to develop a communication bridge between Wingman AI and TAK-Mil. And this consists of a publish subscribed based notification service, which when certain important events occur within Wingman AI, such as new models being uploaded or updates being pushed to existing models, this triggers a notification to be sent out through the system, which can then be intercepted by TAK users and interested parties and consumers like Watchtower. More on that later. And these messages contain any information that a user would need to either pull the models directly onto their device for use in the field, or if this is not feasible, communicate with the models remotely through Wingman's model inference API. And we just have another quick clip of what the notification service looks like. It's playing. Okay, and now just to give a couple of real-world examples of how this technology can be applied. So for instance, say I'm a first responder who's tasked with aiding in the relief of wildfires. During my work, I encounter some potentially hazardous or flammable materials that I'm not able to identify. I can reach out to the UEM system in search of models that were trained to apply to this use case. Once I have the model pulled, I can start testing it in the field, start collecting sensor data, which again is then relayed back to the model developer who can make updates to the model as needed. Or maybe I'm a drone operator and I find that the model that I pulled from UEM struggles to identify targets of interest when they are located on a specific type of terrain. I can, again, provide feedback to the model developer along with any data that I've collected for this specific case. And the model developer can then, again, push an update based on my feedback, which is then rapidly deployed back through the UEM system and back to me. So moving forward, we're looking to, here, I'll just play the last clip real quick. But moving forward, we're looking to expand the model catalog that's being made available to TAK users by incorporating several external model repositories into Wingman, namely the TAK-Mil model repository and Hugging Face, which is a very popular model repository that currently houses over 1.7 million machine learning models. But up until this point, Wingman AI has been the main producer of models in the UEM system, with Watchtower acting as the primary consumer. But a great emphasis has been placed during development on standardization and decoupling. So models don't have to come from Wingman and models don't have to go to Watchtower. The door is open for other potential model publishers and consumers. In fact, this has already been achieved with Prospero. So we're always looking to collaborate with new model systems. If you have a requirement to manage machine learning models at the edge, or you have any questions about the UEM system, please feel free to come talk to us after the presentation. We'd be happy to answer any of your questions. Thank you.
Good afternoon, everybody. My name is Dan Daly, and I'm an AI scientist at Sherpa 6. And I'm here to tell you about our project Watchtower plus Artificial Intelligence Management, also known as Watchtower plus AIM. So, for those of you who were at Jeremy's brief earlier this afternoon, you probably already know about Watchtower. But for those of you who don't, Sherpa's main flagship product is Watchtower, which is a large-scale device orchestration solution built for the tactical environments. It is built for configuring, managing, and updating tactical devices. We currently have over 60,000 devices managed in the field, and we have customers both within and outside of the DoD. Now, Watchtower plus AIM is our main project here, and the goal of that project is to add artificial intelligence model management to Watchtower with the goal of reducing cognitive burden on the warfighters. So we do this by integrating with TAK-Mil, developed by BBN, and by collaboration with Technergetics and all of our other companies on this effort. So, as an update on our progress, right now we have developed the ability to upload models to Watchtower. We are able to receive models published by Wingman that Josh just talked about through the AI Passport message broker. We can provision models to EUDs, and we can enforce policy on those models. The policies that we have developed are time, identity, and location. And we are currently finishing up some remote model access work through ATAK-Mil, allowing users to execute models both locally and through remote servers. In the future, our plan is to add analytics, so we'll be working on that next, so that users can identify how models are being used in the field. So for the majority of this presentation, I'm going to take you on a tour through Watchtower plus AIM and show you how we manage models through Watchtower. So how do you add models to Watchtower? Well, here's our add model page in Watchtower, or our models page in Watchtower. It lists all of the models that are uploaded to the system. To add a model, we hit the Create a Model button up at the top, and that brings us to a page that will allow us to create a new model. Models are created by putting all of your model executable files into a zip file and then uploading that directly into Watchtower. Users have the opportunity to input various aspects or parameters of the model, such as the algorithm, the framework, the developer, to help in managing the models. So once a model is uploaded, we can then create releases or versions of that model. And so here is the model release details page, which allows us to manage the model directly once it's uploaded. It allows users to update models, and it also allows users to get information about the models. If you include a README markdown file within the zip package, then that file is displayed within this page. All right, so once models are in the system, how do we get them onto the device? Well, the way we do that is through what are known as kits. So a kit in Watchtower is the basic building block that we provision to devices. Kits include apps, plugins, policies, models, data products, all of which are grouped together and are delivered to the device. So right now, Watchtower supports a variety of platforms: Android, Linux, working on Windows, Kubernetes, and a lot of others. Right now, AI model management is devoted to Android and Kubernetes. So now, to add a model to a kit. So once models are actually in the system, a user has the opportunity to add them to a kit. There are three options. A user can choose to make the model, default the model to install to a kit. It could be made available for a user to download later, or it could just be made unavailable. Once models are in there, we want to wrap policies around them. So it's possible that an administrator may want their model to be available to the warfighter 24/7, but that's not likely. So right now we have policies that allow the user, that restrict the users from using them based on their identity, based on their location, or based on the time of day. So here's a couple of pages that describe that show what this page looks like. We are able to combine policy types. So for instance, you may want a user to only be a specific user type to be able to access the model between, say, 8 and 5. And that's allowed within Watchtower. The other thing that we support is a firewall type policy for evaluating, or a firewall type rule for evaluating these policies. And so if you want to have multiple rules or multiple policy types for your models, for a specific model, then we tier them, and so we run top to bottom, and the first policy that is evaluated to true, that's where we choose to deny or allow access to that model. All right, models do not run by themselves. Of course, they need supporting apps or plugins, for example, TAK plugins, to actually execute. And so we have supporting apps page within Watchtower, so you can upload all of the apps, such as ArcTAK from Kitware, to provision to the kit to support the model. And those are uploaded and installed similar to how models are. We also allow support of data products, so if there's additional libraries or additional information that the model needs to run, those can be supported and put into the kit as well. All right, with that, that gets you your kit. And so now, how do you get the kit onto the phone? Well, what we do is we promote that kit to production, and at that point you cannot make changes to the kit. And then you have a QR code, which you can scan with a factory reset device, scan the code, and provisioning is off. And that will start the process of downloading all of the apps, models, plugins, policies that you've put into the kit. That'll put it onto the device. From there, once the device is actually provisioned, we have an app known as Watchtower Mobile that is placed onto the device. That app manages the apps and plugins and models that show up on the device. So when you go into that app, the user can see specifically what models have been installed on the device, can also see which models may be available, and can also see which models may have updates. So you can update models that are already provisioned to the device. All right, let's just see a quick example here of the policy management in action. So this is the VizDrone model that was seen in Josh's presentation just now. The VizDrone model is an object detection model based on drone imagery. So what you do is you take a picture and then the model tries to tries to classify the objects in that image. So here's an example of a military convoy. And so a bunch of trucks and other vehicles, and VizDrone tries to predict what kind of vehicles those are. So here, this is an example of execution allowing as normal. However, if we turn the policy off, if we say, let's deny this model, well, we might deny me the slide. There we go. All right, so if policy denies access to the model, then when you click predict, you don't get that classification of vehicles. You get the error that inference could not be performed with that model. So, all right, well, I think I'm just about out of time, so that concludes our tour through Watchtower plus AIM. If you are interested, please come talk to us after this talk. We will also be at the demo tables tomorrow, starting around 2 o'clock, and we would love to talk to you there. And thank you much.
Good afternoon, everyone. I am Caitlin Jenna. I am here with Josh representing Technergetics, and I'll be telling you a little bit about our contributions to the data collect effort. I suspect I don't have a lot of time left, so I'll try to be brief, but just as an overview, this team has been working to pave a path for raw sensor data that's been collected in the field to be transformed into structured, rich with context data sets that are ready to power the next iteration of machine learning models. So in other words, we're trying to turn data into knowledge, and we're trying to provide a means to share it with others. So this is enabled through the Solink ontology and Fuel AI. So for those who might not be familiar, Fuel AI is our platform for efficient sensor labeling. It supports several different labeling modes, and it has direct links to external data sources, the most relevant in this case, of course, being TAK and TAKServers. It's operationally deployed through DAF CloudWorks and is available in all security domains. And as for Solink, that's where we will begin. Hopefully we'll get this to play for you guys. All right. So we know that every mission is different, and everyone has a different idea of how to best represent their data. But when ontologies become disconnected or misaligned, it hinders data discovery. So our solution to this problem was Solink. Solink is a custom high-level ontology that is tailored to the situational awareness use case. It's API accessible. It is based on an open specification that is interoperable with Air Force and Army systems. And it can be adapted and integrated into existing ontologies. It's also designed to be user-extended through the use of our interactive ontology builder in Fuel AI, which I hope you have been getting a glimpse of over here. And it serves as the basis for otherwise disconnected ontologies to be related to each other. So no more searching for vehicle and missing all the labels or all the annotations that were labeled as car or truck or so on, because Solink is smart enough to make those connections. Solink is also augmented by our memgraph database, which enables some fast and efficient queries of annotations, media, datasets, so on. So moving on, I mentioned making these connections, but before we make these connections, we have to collect the data. So through the use of some BBN-developed plugins, such as POSMove, we are able to collect sensor data from TAK-enabled devices, along with mission data, as well as COP messages. And then we can, this data makes its way to TAKServer first, and then can be retrieved through the TAK management page. From here, you can authenticate with TAKServer, search for missions, and filter down your data. We have a few different filtering methods, one of which is auto-filling filters based on a selected COP message. So if there's an event that you're interested in, you can hone in on the data that was collected at that time. Users can also preview and download media, and they can do a bulk selection of media items for upload to the data catalog. From the catalog preview, you can view the media items that will be available for labeling, and if there's any additional information that is linked to these items, such as COP messages or sensor data, that will be considered context. And this will move along with that media item throughout the labeling and dataset export process. All right. So once we're working with media that has been cataloged with context through the TAK management page, which you just saw, users can view that context during labeling. So this context includes tags, some of which are auto-generated based on the context that was selected. And this is just to give a quick overview of the media item. It intends to give the labeler, whether that's a user or some type of autonomous system, a better idea of where this data came from, and maybe some information that may not be obvious upon first glance. Our labeling system has also been upgraded to allow for predicate annotations. So predicate annotations is a concept that has been enabled through our use of the Solink ontology. Basically, it's the relation of two classes. So this creates another detailed annotation. For example, you may have a person and a weapon in your image, but a person holding a weapon tells a much different story. So with predicate annotations, you can capture those associations, and this adds another layer of context to the data. So we can hopefully identify these crucial actions and events. And then lastly, once you are satisfied with the data that has been labeled, you can create a data set right from Fuel AI. So these data sets are available in various formats, including CSV and JSON. And the data can be organized into buckets such as training, validation, etc. They can include basic as well as any predicate annotations that were created during labeling. And once they are created, they're available for download. They're also available for upload to the data catalog, and they're available to publish to AI Passport. For those who may not know, AI Passport is the platform that we use to pass messages between systems. So when a message is published to AI Passport, signaling a new data set is available. It is then available for retrieval and usage by platforms such as Watchtower, Prospero, or really anyone who's granted access to these message publications. So this process enables data sets to reach those who can use the data for training, upgrading their models, and ultimately producing new and improved versions, which will eventually make their way back on to TAK devices. So now, at this portion of the life cycle, of course, the testing and redeployment of these models, that's more a process that's handled by Wingman, which my colleague Josh mentioned previously. So that's about where we end. But overall, we made some strides to enable the machine learning lifecycle through establishing these Fuel AI-based connections, providing the power to curate and organize context-rich data, and being able to harmonize that data through the Solink ontology. I believe I'm running really late here, so thank you for your time. If you guys have any questions or want to have a discussion, please have a chat with us. Thank you.
Hello, my name is Jeff Rye. I'm a principal researcher with CivTAK. We are teamed with BBN to build the Prospero system. So BBN, we have Sarah Jeter is here, and Nate Sewell is working with us. Under Prospero, under this CIBR effort, we are working on data capture and collecting the provenance for those data. Where did those data come from? Where are they being used? And exploiting that provenance to improve the machine learning of the systems that consume those data. We have a live demonstration of some of our data capture techniques. Sarah will be giving that in the demo room tomorrow afternoon, so I'm not going to cover that in great detail here. Instead, I'm going to talk about our provenance, what that means, and how it applies to machine learning. So Prospero builds on some techniques we developed for the intelligence community. In that world, we were tracking intelligence projects and their conclusions and drawing links from raw sources, from upstream observations to the actual conclusions that were made, and then attaching information about appraisals of those quality and confidence judgments in support of those conclusions and helping analysts figure out what sort of claims they can make about them. For ATAK-Mil, we're applying those provenance chains to datasets, models, and applications. And we're, again, looking for those upstream properties of our datasets, whether they have licenses associated with them, whether they're sources that are restricted. Perhaps the sources have captured data and aren't willing to share them with all of the community, but want the community to know that data exist. And perhaps there are quality aspects of the data. We can look downstream in our provenance information to see where are data being used, where are models being used, how much impact will it have if I as a developer go and improve my model? Do I have a lot of reach here? Is this a place where it makes sense to spend time and effort? So Prospero is built with a couple of components at heart. We have OpenIris as a REST API server that exposes routes for capturing and for querying those provenance data. We have a web-based front end, Mira, that users like you and me can use to inspect those data. And then we have the components that Sarah and the BBN team are building to do capture on end user devices, to capture imagery, audio, text, movement data, whatever those aspects of those data are out on the end user devices, and then bring them back into the TAK ecosystem, bring them into the ATAK-Server, and do so while capturing provenance, saying where these came from, so that we have that lineage and we can make claims when we reuse those data, so that we can recognize the existence of new data and apply them to existing models and applications. All right, so let me give I talked about provenance a little bit. Let me give a quick tour of what I mean by that. We are building with the provenance, the Pravo ontology. It's a W3C specification. Uses entities to track things that we care about. These would be in the IC community, things like tweets, images, and upstream reports. We link those to activities as things that those entities are used by activities, analysis in this case, and the activities generate more entities, and we make chains of these. In the IC community, this lets us answer questions about sourcing, so ICD 206 type of concerns. In TAK, as we're looking at ML models and the data and applications that use them, we have entities for the data, activities for training, entities for the models themselves and for the applications, and activities for building them. All of those following the same pattern where we have entities and activities connecting each other. For our activities, we associate them with agents. All of these are parts of the Pravo ontology, so anyone who's used that should be familiar with these terms, but the agents are who is responsible. And these can be software or human or systems. They don't have to be just humans. We track whatever entity is sort of responsible for that activity happening, whether it's responsible for actually performing the activity or whether it's the agent that requested or made an activity come into being. We extended, CivTAK and BBN extended this, the Pravo ontology with our Dive ontology to add in some additional information to support our reasoning. In particular, we're looking at things like appraisals, where we can take quality notifications and put those against entities that we have in our data set, the supported ICD 203 quality and confidence requirements in the IC. We use them, these sorts of appraisals and additional information in TAK to record text, things, aspects, categorical aspects of the of data sets or models or applications. And then we can use those tags to link and recognize when we have new data, say new movement data has come in, to recognize that it's associated with the existing data, and then to look down that provenance chain and say, hey, these data were used further down for this model, we should alert that developer. So let me give a couple examples of what this looks like in practice. We've just heard from the other 5 Civers about the ecosystem here where we have applications and we have the deployments and all of that. Here's a picture, it's a screenshot from, I captured part of the screen from our live running Mira application, actually showing what this looks like in a particular case. And so here, sorry, it's a bit of an eye chart, but bear with me. At the start, we have kitware using Fuel AI to publish a data set. Once they've got it there, they train a re-ID model with that data set. Then they release the model using Wingman AI. And then some admin uses Watchtower to actually build a kit, to build and produce and provision that kit. Once that is fielded out to some end user device, we use the TAK sensor ATAK plugin to accumulate data from the field, additional opportunistically captured imagery, audio, and such. And then we feed that back into the system. Prospero here recognizes that the new chip data coming from that live deployed application aligns with existing data, and then can alert kitware that there are new data relating to their re-ID model, and then they can make that assessment about whether it's useful to retrain their model with those new data, or whether it's time to augment their data set or take other action. So we also use it very much on the front end, on the developer-focused view. And here we've been working pretty closely with Certus Innovations as part of their model development process. They started off our presentation here. They've been using Prospero to track information about their model development. And here's what that looks like. We start with some helicopter audio data sets that came from a commercial provider. They merge those data sets and add class labels. They trim and shorten the audio clips. They merge those into a combined helicopter data set. This is all actual activities they took to clean up those data and make it ready for their helicopter model, and tracked in a live running Prospero instance. In fact, the link there at the bottom of the screen it works. It goes to a live system where you can go and view this very same provenance graph if you'd like. They add some distractor data. Once those data are, I wanted to note, gotcha. So the distractor data, here I've applied a defilter to take out some of the clutter in the graph, the actual agents that are responsible for these distractor data, but all of these are backed with links, URLs, and attribution back to the public sources where those distractor data came from. So when we want to dig further into what exactly is going into the data sets we're using, we can get to that ground truth by looking back up the provenance graph. They balance the class labels, they train the model, and then I wanted to note when they train the model, we actually can record stuff. In addition to the data, we can record things like what the framework is that they're using. So they're using ResNet in some cases, RexNet in others, and we track that as formal entities within the provenance graph so that you can make trade-offs there and say, okay, how does this class of model compare to this other class of model? And then ultimately they do an evaluation of the model that they produced and write down the evaluation scores. So this is all live stuff that was recorded from their training process. They have Jupyter notebooks that call out to our publicly running system and record this information. So where are we and what are we doing going forward? We've got our source code is up on DLE. If you want access to that, talk to me or Sarah Jeter, and we'll get you set up, get you access to the source code for everything I've just talked about. We're at CivTAK, we are hosting currently the live running systems. We have 3 of our components up and running right now. We have the backend system, OpenIris, is running on port 8000. We've got the TAK-Server that's used for collecting data from those devices in the field. That's on 8081, and then our user-facing front end is on 8050. All of those are publicly accessible. You can come find me. I can give you the links to them. You don't have to memorize any of that. To date, we're about halfway through this server. To date, we've been focusing on the capturing and display of provenance data. And as we move forward here, we're looking at exploiting those data. So we're working currently with Certus to compare models, something similar to weights and biases where we can look and say, okay, given evaluation results, how do these particular models compare? And what other models should, if I look upstream in provenance, what other models should I be comparing against? That's sort of the next area that we're going. But we're actually looking for how we can apply it to your use case. What do you have where you want to know where this came from? And let's talk so that we can exploit provenance for your use case. Contact info is there. Sarah will be over in the demo room with the live demo tomorrow, but come find either of us to talk more about what we've done here. Is Ralph in the room? Ralph, did you want to say any final words?
Thanks, everybody. So I think this is really important work for the long-term viability of TAK, because I think we need to be leveraging and exploiting both the data and the way we handle models robustly in TAK. And so my My ask before we take questions, if there are any, is if you are a government organization that thinks they need to leverage their data, get with Dave Canestrere, who is about halfway back, to talk about how we can do a Strat Phi or Phase 3 to move this into integrating with your organization in the TAK Product Center. And with that, the team's ready for questions.